Okay, so canceled class tonight so that you guys can have a Labor Day off and I can have Labor Day off. Hopefully, everybody is hanging out with family and friends, doing the barbecue thing. But still wanted to cover some stuff for class tonight. So this will be the first of two videos I'm going to ask you guys to take a look at. But nothing here was super complicated, and we'll probably touch on all of this as a refresher next time we meet. But what I wanted to do today is, or in this first video, is really just take a look at strings a little bit more in detail. Last week, we spent a lot of time looking at variables and looking at the different data types, primitive data types um, that you will use frequently within Java. Um, I mentioned last week, and we've used strings before, and you guys used them in your assignments and all. Strings are kind of anomalous. They're in some regard considered primitive just because we have to use them and we use them frequently. But they're actually a lot more complicated or not complicated, but they're a lot more involved than your integers and your doubles and your booleans and that sort of thing. And so what we're going to talk about today is a little bit more about strings, something called escape characters, which can become useful as you try to print things into the screen or create output. And then we're going to talk about some operations. There are actually quite a few operations that you can do with strings. So far, we've only really talked about using the concatenation operator, the plus sign. Something like this. Um, let's see, just as an example, right? We've seen some of this, Chris. Oops. And if we have a last name, we might say Merritt, right? And then we've seen this concatenation operation where we would combine first and using the plus sign would concatenate a set of strings together, right? Oops, what want to do last. If we run this with a semicolon at the end, would be helpful, right? What we'll see is that the variable first that we created that has the value Chris stored in it, the variable last that we created that has the value Merritt stored in it, and then when we want to print these to the screen, we can use this plus operator to concatenate those strings, right? So and concatenation just merely means combining them together. So far, that's kind of the extent of sort of primitive operation that you might consider that a string has. But there are lots of other things, as you can imagine, you might want to do with a string. I mean, if you think about just everyday word processing that we all probably do with Microsoft Word. I mean, you have things like find and replace, functions like changing everything to all uppercase, for instance. If you think about word counts and letter counts, sometimes that's obviously useful. Um, trying to figure out if something begins or ends with a certain string or with a certain set of characters can be useful. All of these things become useful in the world of programming, especially when you're dealing with getting input from users. As you can imagine, getting, you know, if you ask the user to provide their date of birth and they type in their phone number, a good way to confirm that they're providing the input that you're requiring is by looking at the composition of what they typed. And string operations are really a good way to help you do that. So what we're going to do is we're going to look at a few escape characters. There are a few more than what I'm going to just discuss here. But if you just Google escape characters and Java, you'll find a list. But the things that we'll probably care about the most are probably just using new lines, creating new lines, and also how to input quotes inside of quotes. That sort of thing can get a little tricky. So let's go forward with this. I'm gonna get rid of this stuff, and let's do this. Let's start with a simple one. Right. Sometimes we want to put quotes in or titles in quotes. And if we were going to print this, my favorite book is, right? And if I add the title there as a variable, so basically what we're going to do is we're going to store Great Expectations as the name of, or as the value stored in the variable called title. We're going to print my favorite book is, and then we're going to print whatever is stored in that variable called title which at this point in time would be Great Expectations. If we run this, we would get this output, which is what we would expect to see. But suppose we wanted to put quotes around Great Expectations. I know it's a book, so it should probably be underlined, but for the sake of the example, we'll say it's a journal article, and we want to put quotes around it. Why not, right? So what you can do is you have and I always get this backwards, but I think this is the backslash is the escape character, right? So if you do backslash and a quote, that will put a quote inside of your print statement. So whereas this quote and this quote are actually the beginning and end of the string that we're trying to print, of the literal string that we're trying to print here, this will be viewed because it has a backslash in front of it, and then the quotation mark. This will be viewed as, hey, we really just want to print this actual character. And so what we can do on this side of it is put another string, literal. You'll notice there's two quotes there. And then we'll put another escape character and the quote again. This time when we print this, you'll see that we get quotes around Great Expectations. And the reason that space is there is because there's a space right there. If we remove that guy, we should get the output we're looking for, right? So escape characters are ways to get things inside of strings that are maybe otherwise used as syntactic controls or syntactic components of the language itself, like the quotation marks. If we didn't have these here, and I'll just remove these for now, if we didn't have the escape character here, we would see an error, right? Because what the compiler's seeing is that, hey, there's two quotes here. This quote belongs to this quote, and then we have an extra quote right here, right? And that's why you see the exception there. It says unclosed string literal, and so you'd simply resolve that is by putting the escape character there, so that it knows that, hey, we really just want to print the quotation mark there. Another one that you might see often would be using the new line statement or the carriage return. So if I take off the ln at the end of print, right? What that's going to do is that's going to keep the cursor. Put a space back in here. So if I print this now, right, you'll notice the difference here. There's a print statement and there's a print line statement. Print does not include a carriage return at the end of the print line. The print line statement, the ln there, does a carriage return in the line feed so that our cursor would end up on the second line or the next line. So if we were to run this, what you're going to see is something that's all jumbled together, right? The first print statement terminates right here at expectations. And then because there's no ln on the end of the print statement, we get no carriage return. And so the next statement executes, and it's basically right where the other one left off. So sometimes you can you can play with this. Obviously you can use print line, that's perfectly legitimate, but sometimes perhaps you want to actually control it a little bit better without having multiple statements. And so what you can do is use the escape character, and n would give you a carriage return or a new line. So if we run this now, you'll see that as soon as it hits that carriage return with that escaped character, it's going to drop down to the next line, and we'll get basically the equivalent of a print line statement. But again, this can be useful in a lot of different ways. If you wanted to use a tab, you could do escape character T, and if we run that again, what you'll see is you'll get a tab between the two statements. If you wanted to print a backslash, you could do two backslashes in a row, right? And then that's how you would escape out your backslash. If you just had one backslash, it's going to think that something's wrong, right? Because it's going to think this is an escape character, and so the thing that follows it is something that you're trying to print literally, but that's not the case, right? So if we actually want to see a backslash, you could put two there. So again, if you Google escape characters Java, you'll find a nice list, I'm certain. And if you're ever trying to figure something like that, you can work with that in that way. Okay, so that's the easy part. Let's start messing with a couple of other things. So with respect to your assignment, I ask you to do a few things, and I'm just going to enumerate them here to make sure I don't miss them. I'm going to ask you to talk about the length of the string. I'm going to ask you to convert it to uppercase. I'm going to ask you to check and see if something ends with a certain value. I'm going to ask you to tell me what index a particular letter uh, is at. And I'm going to ask you to find and replace a couple pieces or a couple substrings within your string. Okay? All right, so let's do this for now. Okay, so let's start talking about strings. I said they're actually a lot more complicated than some of the primitive data types, so than integers and booleans and doubles and that sort of thing. Um, the reason that string is actually capitalized is because it's actually not a primitive data type. It is a string operator, or I'm sorry, it's an object. It's a class on its own. And we haven't really talked about this much, and we're not going to talk about it a lot now. But because this is capitalized, you can infer that the string object is just that. It's an object, which means it has properties, which means it has methods that you can apply to it. It means it has basically advanced things that you can do with it that you can't do to other data types. And that's kind of the layman's term. Later on in the semester, we'll explore more about why this is the way that it is. But for now, all you need to understand is that there are really a lot of things that are already built into Java that you can do with strings um, that you don't have to build yourself. Somebody's already built them for you, and so we can just use them essentially. But one thing that's important to understand about Java in general is that Java, most things in Java, if not all, are where there's an index involved, means or uses a zero-based index instead of a one-based index. And what I mean by that is, if we talk about the word Java as a string, essentially the J is at index 0, the A is at index 1, the V is at index 2, and the second A is at index 3. So if I wanted to know what character we're at position 2, it wouldn't be the A. We wouldn't be 1, 2. It would be, we would start counting at 0, 1, 2. So the character at index 2 would be the V. Um, that's kind of important because all things throughout Java, and we'll run into, well, not all things, but I think all things, most things throughout Java are zero based, and so we'll run into that quite frequently. The length of this string would be 4, right? There are 4 characters there, and the index of those characters begins at 0 and ends at 3. Okay, so we'll run into that in just a moment. But let's start with that. Let's start with looking at the length of a particular string. You'll see here that we've declared a string called, I'm just going to call it S for now, so I have to type less. String S, S is our variable, and inside of our variable S we have the phrase welcome to Java, period. And let's go through and let's look at these 5 different operators that we can do on this particular string S that will tell us attributes about this particular string. Okay, so let's do system.out.println S. And the way that you would do this is you would type the variable or the string literal or anything that you want to work with, the string itself, and you press this dot operator, and you don't put it in quotes. Sorry. You press the dot operator, and if you're using NetBeans, what you'll see is this nice little window will pop up. And basically, what this window is doing is it's telling you all the things that you can do to S. So S is a string, and these are basically all the operators that you can run, all the methods that exist that you can run on a string. Okay. This is actually, we haven't talked about methods yet and some of the more, think of it as subroutines that are out there. We will get there. For now, you're just going to use this though, and you don't have to understand how or why it works. But if we wanted to know, say, the length of S, right, the number of characters, we could simply look down here and see if we could find something called length or that talks about length. And what you'll see is that it exists right there, right? Now length, if you click on it, this will tell you up at the top, this will tell you a little bit about the method, okay? And what it's saying is that if you use this value, or I'm sorry, if you use this method, it's going to return an integer data type that makes sense, right? It's going to tell us how long, how many characters are in our string. So if we double click on this, or you can just continue typing it, whatnot, that's fine. If we end right there and we run this, what we should see is 16. And if we count this, just for the sake of posterity, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 characters in that string. And the way that we did that is we said we want to know for string s what the length of that string is, and this is the dot operator, and then this is the method that we want to use that's going to give us this attribute about s. Okay, you could do something like this if you wanted to. Um, you don't have to put it in a variable. You could say Java, because Java is a string, right? I have it in quotes. I could press that dot operator, and I get the same list of methods and operators um, as if I stored it in a variable first, right? So if I wanted to know the length of Java, the string Java, I could do this, and now what we should see is 16 and then 4, right? Java has a length of 4. Pretty straightforward. The nuances of using it are a little bit different than maybe what we've seen so far, but that's okay. It's still not super complicated, and I think you guys can follow along. So let's say if we wanted to print um, S, if we wanted to make S all uppercase, we could type S, hit the dot operator. NetBeans is going to help us out, and we could look through this list of operators and see if we can find something that looks like it might help us convert this to all uppercase, right? Um, Length we already used, replace all, split. Wait, there's this thing called to uppercase. Let's click on it. And when we click on it, we see that it converts all the characters in the string to uppercase. Um, it returns a string, which is fine. That's what we're just going to print it for now. So if I double click on that, I put a semicolon at the end, I run it. Now what we see is that our previously not all uppercase is now printed to all uppercase. Now, an important distinction here is to remember is that we haven't changed anything about s, right? This is just taking s, converting it to uppercase, and then it's just printing it to the screen. We're not reassigning anything to the value of s, to the variable s. If we print s just by itself, after we do this uppercase statement, you'll see that s remains intact. It hasn't changed, okay? The only way that we change values stored in a variable is using assignment, which means using that equal sign. So if we did something like this, s equals s dot to uppercase, now what we'll see is that when this statement gets executed, we're merely printing to the screen that it's uppercase, okay? And s is still looking just like this. When we use this assignment statement, when we use this equal sign, basically what we're doing is we're overwriting whatever was previously stored in S. So while S originally had welcome to Java in lowercase, after this assignment gets executed, what we're going to see is S.to uppercase is going to look like this, and that value right here, this all uppercase value, is going to overwrite whatever is previously stored in S. So that when we print S the second time, we should see that it's all uppercase, right? And anytime going forward after this statement gets executed, as long as we haven't messed with S again, it's going to be uppercase. Okay? So, just to be clear there, we're not modifying S just simply by printing it or by using this method in the dot operator. The only way that would happen is if we use this assignment statement, okay? If we use that equal sign. So we're not messing with it. Oops. There we go. Sorry. Okay. So two uppercase, right? Easy enough. Let's look at something like the next one we have on here on our little short list is ends with, right? So let's see if so we have our string up there s. Ends with is a little bit different, right? You need more than just it's more than just an attribute about s, or it's more than merely just blindly changing some attribute of the string itself, right? Ends with is a little bit different because we have to say what do we want to check and see if it actually ends with. What's the value that we're checking for? Um, Everything works almost exactly the same. We're still going to use that dot operator. Um, we're trying to see if something ends with something. So amazingly enough, good pragmatics, right? We have good method names. Excuse me. It exists. We can use it, right? So if we click on ends with, this looks a little bit different, right? this has something in the parentheses, whereas the last two we looked at did not, right? There's nothing in the parentheses here, nothing in the parentheses here. When we did 2 uppercase, right, you'll notice here there's nothing in the parentheses as well. We'll talk about this more in detail, but later on in the semester. But ends with, you'll see, has something that it's looking for in the parentheses. You'll also notice that the data type it's going to return is a Boolean data type, right? So if we were to look at ends with and what NetBeans helps us or tells us about it, what the documents tell us about it, the Java docs, it's going to say it tests if this string ends with the specified suffix. So suffix. So what we want to put in those parentheses is what we want to test for. We want to say, does our string end with this suffix that we provide in the parentheses? If it does, it will return true. This method will say true. If it doesn't, it will say false, right? We see over here it's a Boolean data type. So let's give it a try. The suffix that we want to check for, let's start with the good case, right? Let's see if it ends with Java period. As you would imagine, if we print this, we should see something that says true, right? We said that this method ends with is going to tell us either true or false. Either it does or it does not end with this particular string. And so let's run it, and we would expect that we would see true, right? Because in fact, S, our string up here that we've declared, has welcome to Java period stored in it, and welcome to Java period ends with Java period, okay? If we take away the period and we check ends with, we should get false, right? Because this is not the ending of this string. Makes sense, right? Java is case sensitive on all fronts. So if we do this, we would expect to see false, right? They don't match at all. Okay. So this is a little bit different, right? We're having to pass this. It's called a parameter. And again, we'll talk about this later. It's called a parameter, a formal parameter, or an actual parameter. And so we're passing this method that's called ends with, this operator for strings, this text Java period, and we're checking to see if this string S ends with Java period, lowercase, and we see that it doesn't. Okay, pretty straightforward. If we change this back to capital J, we'll get a true, as we might expect. Okay. Next thing, let's suppose we wanted to figure out where our first occurrence of the letter E is. If we look up here at our string, you'll see that the first occurrence actually is at index 1. So remember, W is 0, E is 1, L would be 2, 3, 4, 5, 6, right? So let's take a look at this. Let's try and print out. Again, we're going to type S because that's the string we want to work with. That's where our variables is called, and that's where our value is stored. Hit the dot operator. And I want to know what index a particular string or character resides at within the string that we're testing. So here's this great method called index of. This one looks similar to the last method in that it's expecting us to give it some sort of input so that it knows what to look for. If we read about this, it says the return index within the string of the first occurrence of the specified substring. So the specified substring is going to go right here. This method is going to give us a number that's going to tell us where that first occurrence occurs, what the index is of the first occurrence. So if we do index of, and we want to check for, let's say, the string E, we put a semicolon at the end, what we should get back is the number 1. That's what it should print. It should print the number 1. And what you see is that right there, right? System.out.println, we're going to print the first occurrence of the index E, or I'm sorry, of the value E in our string S. The compiler goes and looks at S. It says welcome to Java is stored at S, and then what it's going to do is going to look for this letter E. If it finds E, it's going to return the value of the index where E resides. Again, W is 0, E is 1, and so forth. So that's why we got the letter 1. If I did capital E, as you might expect, it does not exist up here, right? Everything is case sensitive. It does not exist. And so what this method will do is it will return a negative value. It'll return a -1. If the string does not exist in the value that you're looking for, in the string that you're looking through, you will get a -1, essentially. Basically telling you that, hey, this doesn't exist. And that makes sense, right? Because there is no such thing as an index of -1. Everything starts at 0 and goes to the right. So we can never have an index of -1. So if you see any kind of string operator returning a value with a -1, generally speaking, that means that it wasn't possible to perform that operation, or that the value or whatever you were doing or looking for didn't exist. Okay. If we were to look for the first value of the lowercase a and run it, you'll see that we get 12. If we started counting here, we would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So there's our 12th index. And in fact, it has an A, and it's our first occurrence of A. Pretty straightforward. And one more, just because we're going to use it in the assignment. Let's look at replace all. What replace all does is basically the equivalent of find and replace that you would use in an office automation package like Word or Pages or something. Again, we're still working with our string s up here, and so we're going to say s dot. We can't remember what it's called, but if we look down here, we know that there's a replace all. We're going to click on that. If you look at this one's even more advanced maybe than the last two we've looked at. This one takes two arguments. This first argument being what we want to look for. So this would be the find. This represents the find. And then this represents the replace. So if we find this string in our text, or in the string we're searching through, we want to replace it with this string right here, right? Pretty straightforward. And so in our example up here, what if we replace Java with University of Richmond? Right? What we would expect to see here is that our string s, right? We're still working with s. If we go look at what's stored in s in memory, we're going to find string s. It's going to say welcome to Java. What we're going to do is we're going to take Java, if we find Java, and we're going to replace it with University of Richmond, right? And then we're going to basically print all of that out to the screen. So if I run this, we should now see welcome to University of Richmond. Again, no assignment is taking place. We're not changing the value of any variables. All we're doing in this particular application is printing it to the screen. Unless we use that assignment statement, the equal sign, we're not changing anything. We're merely just printing out the results. Okay, if we do this, now we're going to actually be printing whatever is stored in that value, in that variable s. And because we had this assignment statement here, we're overriding, whatever was previously stored in s. That's straightforward. Okay. So this will get you most of the way home with respect to your assignment this week. If you have any questions, obviously you can reach out to me, and I'll be glad to help you out. All right. We have everything. Yep. Cool. So happy coding. Let me know if you guys run into any problems.